So we are already aware of definite integral, indefinite integral. Definite integral, what is the significance of definite integral? It acts as a sum or the area. If we have to calculate the area of a curve, we basically integrate it. Okay, so like we have a very basic integration. So like we have integration like this, integration of 0 to 1 x square dx.
So
So
first we will integrate, it become x to the power 3 by 3.
okay, very good.
And we just put uh,
The limits.
substitute, yeah, so 0, which anyways it's, so we can directly put
So what it will be?
um 1 by 3.
1 by 3. Very good. Okay, so this is like the formulae we know. Okay, so let us look into some important properties of definite integrals.
Hmm.
So I will be writing some properties. You make a note of that. So like these are the properties of definite integral a to b f of x dx. It is equals to a to b. So what I did, I just reverse
Inter-
the limits. So whenever I reverse the limits, a minus sign is introduced. So very important property.
hmm.
A to b fx of fx dx is equal to minus b to a fx dx. Integration of a to a fx dx, it is 0. Then we have integration a to b. So we have a function, like we have a constant c dx, where c is a constant. So c we can take outside. So it will become integration of 1 dx. So integration of 1 will be x. So it will become b minus a. Similarly, we have sum of two functions, okay, fx plus dx. So if we have sum of two functions, so integration of sum of two functions will be like we can break it up. Integration of first function plus integration of second. So this is what we will get. And if we have a constant multiplied by a function, if we integrate it, so here we know that constant we can take outside. It will be integration from a to b f of x dx. Then the next property is okay. Similarly, difference also we can take like that's c of integration a to b g of x. This is clear. Then what next? Okay, very important. So this property is very important. So if A is less than C is less than B, so C is like any number between A and B, anywhere between A and B, then limits we can like break it. So A to B it can be A to C fx dx plus C to
Oh,
B. Like this is applicable only when C should be between A and B. Like C can be any number between A and B. So if C lies between A and B, then we can write this. So these are like some important properties. And so now you will we will discuss this comparison properties of the integral, like some more properties. So I have a function fx. If this function is greater than or equal to 0. So if this
hmm.
function fx is greater than or equal to 0 for uh, x lying between any a to b, then integration from a to b fx dx will be greater than or equal to 0. So it's very easy property. Like if function is positive
Hmm.
in an interval, so the integral in that interval will also be positive. Like here we can, it's understood that this
Yes,
function is
sir.
positive, so integral will also be positive. It's a interesting property. Second property is if f of x is greater than or equal to g of x. So we have two functions in which f of x is greater than g of x
Hmm.
for any interval a to b. And if it is so, then we can say that the integration from a to b f of x will be
Hmm.
greater than or equal to f of x dx. So this integration of f of x will be greater than or equal to g of x. So this is also understood. Like if uh, fx is greater than gx, then its integration will also be greater for a particular interval. And one more very interesting property, if like I have a function which lies between small m and capital M, like small m is the minimum of the function and capital M is the maximum, like global minimum, global maximum of the function for an interval. So in an interval a to b,
Hmm.
we have something like this. Then we can say that m times b
Hmm.
minus a is less than or equal to integration of a to b f of x dx is less than or equal to capital M b minus. So this is an interesting property. We can prove it. Let's prove it. Very easy to prove. So see, it is given that function is between small m to capital. Now, if I integrate the all the terms in the range a to b, now tell me one thing, like m is a constant, so it will
Yeah.
become b minus a, because m we can take outside. Differentiation of one will be x, and
Hmm.
if we put limit, it will become b minus a. It will be as it is, and it will
Later.
become capital M b minus a. So this property we prove. So whenever we know the like limits of a function, we can
Hmm.
integrate all the terms and we can get the limits of an integral of a function.